Good morning, my YouTube viewers. It's Crystal here. I'm just here because I wanted to give you another code review. This code review is going to be on Kaggle's Playground Competition. It's going to be Season 3, Episode 16. And it's regression with the crab age dataset. And what you're supposed to do is you're supposed to predict the age of the crabs. And so basically what I've done is and I use TensorFlow to solve this problem, but whenever I finish it, I will show you the different submissions that I made, because I used some submissions that were not TensorFlow as well. And all of my Jupyter notebooks have been made public, so anybody who wants to view them can view them. So the first thing that we're going to do is we have to create the program, and I created the program using Kaggle's free online Jupyter notebook, and it's stored in my account. After we create the program, we want to read the problem statement, and the problem statement is basically predict on crab ages. And then after we've read the problem statement, what we need to do is we need to import the libraries that we're going to need to make the predictions. So we're going to import pandas as PD, which creates the data frames and processes the data. We're going to import NumPy as NP, which creates NumPy arrays and performs numerical computations. We're going to import OS, which goes into the operating system. We're going to import SciPy, which is a scientific library, and we're going to use that to make statistical computations. We're going to import sklearn, which provides machine learning functionality, and then we're going to import TensorFlow, which creates our neural network and provides deep learning functionality. We're going to import matplotlib.pyplot as PLT, which visualizes the data, and we're also going to import Seaborn as SNS, which visualizes the data statistically. So after we have imported our files, what we want to do is we want to use OS to go into the operating system and get the files. And we've got 3 CSV files that are going to be used, which are train, test, and sample submission. Then what we do is we use pandas to read the files and convert them to data frames. So our 3 files are train, test, and submission. So you can see the train file here. You've got the different features as well as the target. You've got an ID, a sex. Believe me, they've got 3 sexes. They've got male, female, and I. I don't know what I is. I don't know what the I means. I don't know that much about crabs. So I don't know if I means infant or I means indeterminate, but it gives you 3 sexes of male, female, and I. You get the length, the diameter, the height, the weight, the shucked weight, the viscera weight, shell weight, and the age. Then we check the information of this train set, and you can see the ID and the age are integers, and the object and the length, the ID and the weight are integers, and the sex and the length, sex is object, and the length, diameter, height, weight, shucked weight, viscera weight, shell weight is float. And one thing that I noticed is the age is integer. So, this is a bit odd. So I think what I might do is whenever I ran up my predictions, I ran it up as floats. I think what I might do is when I finish this code review, what I might do is change all of the values to integers and see if that improves my score. I might do that because my output was a float and it didn't not accept my predictions. But maybe if my predictions are an integer, maybe that would be better. Who knows? Do anything to try to improve the scores. So now we check for missing values. We haven't got any missing values, so that's good. So that means that I don't have anything to impute. We check the test. The test is the same as the train, except for the fact that the test doesn't have a target because we're going to be making predictions on the age with the test set. We check for any null values and we see that we haven't got any null values, so that's good. We don't have anything to impute. And the submission gives you the age, and it's interesting because the age is an integer, so I didn't pick that up whenever I made this code. So if I change the age to an integer, then that might improve my score. You never know. So now what we do is we want to check the train and the test file to see if the columns come from the same distribution, and we use SciPy stats to do that. So to drop is a blank array for a call in test. Stat PV equals stats.ks -2 samp train call test call. If PV, that's your P value, is less than 0.05, print the call is not drawn from the same distribution. And then it says to drop append call, and then you print your to drop, and IDs are not from the same distribution. So I was going to drop the ID anyway, but we went ahead and dropped the ID because it's not from the same distribution anyway. Then I created a heat map. You can see from the heat map that the columns are very highly correlated. So you can see the correlation here, and you can see how highly correlated the columns are. So now what we do is we insert code to remove the columns that are highly correlated. So the columns that are highly correlated are diameter, shucked weight, viscera weight, shell weight, and we drop those columns. And so now what we do is info again. So now we've got sex, length, height, weight, and age. So we're going to analyze the train. So we check the sex, and you see sex has 3 categories of I, M, and F. And you can see the females tend to be older. And now we check the length. So you can see that the higher the length, the greater the age, which is good. They can get all the way up to 30. I don't know if that's years or not. And then we check the height, and you can see that the height, well, the higher the height, the greater the age as well. And you've got a few outliers in there. And now you check your weight. You can see the higher the weight, the greater the age as well. So now we're going to ordinal encode the columns that are object, and there's only one column that's object, that is the sex column, but I went ahead and used my code for ordinal encoding. So now you can see in the sex it's either going to be 0, 1, or 2. Now we're going to analyze the target. So you can see these are the targets. Goes all the way up to 30. But now that I think about it, I'm going to do a little bit more work and see if I can improve my score, because it is integers and not floats, and that might improve my score if I make it an integer. And now what we're going to do is we're going to define our dependent and independent variables, which is going to be y is going to be your target, x is your train, and x test is your test. Because prior to that, just to show you prior to that, we did target equals train dot pop age. So we took age out of the train set. Now we're going to use sklearn's train test split function to split the x and y variables up into training and validation sets. Now we're going to check TensorFlow, and we're going to be using TensorFlow to make the neural network. So we're going to import TensorFlow and its associated modules. And we're using version 2.12 in this particular program. And the reason why you need to check the version is because TensorFlow goes through lots of changes. So, especially in Kaggle, like they had a training program that was done on version 2.3. Well, it doesn't work on version 2.12. So with TensorFlow in particular, since it goes through so many changes, you need to stay abreast of the changes. And one thing that I got an email yesterday or the day before about TensorFlow, about all the neat things that you can do with TensorFlow. But I'm still learning. I'm still trying my best to learn as much as possible. So I can't do all of the things in TensorFlow that they say to do. But TensorFlow, in my opinion, well, it's not just my opinion, it's lots of people's opinion, are that it has a very high learning curve. So I'm still learning it. So now what we do is we use the normalization function to standardize the data, and then so you've got the standardization of each column. And then now what you want to do is you were doing an experiment so we can see what the columns are when they're not normalized, and we can see what they are when they are normalized. And now what we do is we create our neural network. This is a sequential neural network. And I gave us 10 neurons in the hidden layers because I'm just experimenting really. I originally had 5 neurons, and whenever I put 10 neurons in, I had a better reading. And in a previous program, I tried to use the leaky ReadLoo, but the leaky ReadLoo didn't perform as well as the ReadLoo. So I went back and used the ReadLoo. I mean, using this particular problem, I use lots of different algorithms. I use algorithms with TensorFlow. I use algorithms with sklearn. I use algorithms with XGBoost. But I tried my best to get the score as high as possible. So this is your summary of the model. And now what we've done is we've compiled the model, and we've used RMS prop because And if you want to use Atom, if you want to try to improve the reading by using Atom, you can. But I decided to use RMS prop because it's about root mean squared. We set it up for early stopping, we set it up for model checkpoint, and then we train the model up for 100 epochs, and then we checked our val loss and val accuracy. So we trained it for 100 and it was set up for early stopping. And so that's it. It had a MSC of 5.72. And then we graphed the loss, and you can see the loss in the training set is really close to the loss, or the MSC, that's the error. The error in the training set is really close to the error in the validation set. We checked our YPRED, and you can see the answer is a float, but I think I'm going to go back and round it off and make it an integer and see if that improves my score. We check our RMSC, which is 2.39, which isn't too bad. And then now what we do is we're comparing the actual values against the predicted values. And I tried my best to get it to work better, and that's all I was able to get it to do. We created a data frame of the actual values against the predicted values. So I don't know. It says it accepted the floats. It was an integer because it was an integer output, and it accepted the floats. But you can see how there's a possibility that if I make it an integer, it might improve. You never know. Let's just check our target. And this is the predictions. So you can see the predictions. And then we set it up for prepared the submission, and we took the predictions and we put it in the submission, the column age, and we converted it into a CSV file. And this is the CSV file, and that is what I submitted to Kaggle. And I got a 1.5990. So I'm not so sure about making these values integers. I'm worried that it's going to make my reading worse. But that's the way it worked out. So if we go actually to the competition question, and you look at my submissions, you see that I worked on it a lot. I made quite a few versions. I made the TensorFlow version, which is a deep artificial neural network. I did the random forest regressor, which was just slightly better. It was slightly worse. So I used random forest. I used XGB, and then I tried Leaky Relu. And Leaky Relu did not improve my reading at all. So I did try other activation functions to see if I could improve my score. The only thing that's left for me to do is to try the Atom optimizer instead of the RMS prompt. That's the only thing that's left for me to do. But I'm not sure I'm going to do that because I've worked on this for a day, and that's my output. And you can check me on the leaderboard. My best score is 1.59990. and I'm 450 on the leaderboard. So, and the best score is 1.3. So I did my best. That's all I can say is I did my best. So I'm going to go ahead and conclude this video. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap on the bell button next to the subscribe button. I would like to thank all of my subscribers for supporting my channel. If you want to be notified whenever I make a new video, please tap on the bell button next to the subscribe button. And this is the second time I've said that. So thank you for watching my video, and I look forward to making more videos for you in the future.